Alright, so besides the fact that we're splitting this chapter into two tests, this chapter kind of in itself splits up into two as far as what it talks about. Your first three lessons were more so talking about all different kinds of functions and operations on those functions and finding inverses of those functions. This lesson kind of turns, and it takes a different route now as far as the rest of the chapter goes, and we work on square roots and other different types of radicals that we'll learn after this first test. Okay, but for the first one, we're at least going to learn how to graph these and then how to write the equations as far as square root functions go. But it's pretty basic once you understand the parts and the concepts and stuff like that. It's not terrible. So here is the basic bare necessities of what a square root function looks like. It looks like this curve in the blue there. And there's some weird things that go on with this. Okay, first off, you have the square root, okay? And so that's weird in itself. The second weird thing is if my finger would move, there we go, is your domain, okay? Now, like I said earlier when we did the dividing section, as we move throughout the rest of this year, we're going to start talking about domain and ranges more and more because they become more and more important to our problems. They definitely become important with square roots because there are certain types of numbers that we cannot take the square root of. Those numbers are what? At least normally, we can't take the square root of a, what type of number? Of a negative, okay? Now, you guys know how to handle it with i's. We're not doing i's, okay? So basically you revert your thinking going back to, we don't know how to take the square root of negative numbers. Which means the first number we can take the square root of is 0. Alright, so that's why your x's, when you look at your domain, start at 0. X is greater than or equal to 0. That's why the graph, if you look at it, starts right boom there at 0. It's the first number you can literally take the square root of. So that's why the graph starts there. And that's why there's not arrows at both ends. Okay, see that? It's a very subtle but important part to this. This graph does not go on forever and ever this way. It stops or starts right there, but does go on forever and ever this way. It's one of the few graphs that actually don't go on forever and ever in one direction or another. Okay? So that means your domain changes to x is greater than or equal to 0. Your range is the y's that come out of that, and that'll change from function to function, from problem to problem. And so we'll talk about how that differs each time. All right? And then the rest of this page is kind of the same, rehashing the same stuff. Intercepts, not defined, and behavior, stuff like that. Okay, so that's your basic bare necessities of square roots. Any questions on that? Honestly, I'm going to skip over this slide. Okay, cool. All right, so graph y equals x minus 2 plus 5. And then state the domain and range. Okay. The way I used to teach this way more involved, let's say. I used to say, make you a table, get your points, stuff like that. I don't know if it's me wanting to use the calculator more or me getting lazy, but now I say use this. Alright. Use your calculator to graph it. So we go, let me zoom in for you guys here a little bit so you can see it. Okay, so go y equals. Let's get that out of there. And then the problem is the square root of x minus 2, is that right? Okay, so second square root. Everybody see where that's at? X minus 2, right? Okay, I don't have the problem in front of me, so if I'm doing it wrong, you guys gotta tell me. Plus 5? Okay. Now, biggest thing for this, when you plug these in your calculator, right now the x minus 2 is what's underneath the radical, right? And the plus 5 is not. So you can't just go square root x minus 2 plus 5 all straight away, because it's going to put it all underneath the radical. You need to make sure you hit your right arrow right there to get out of the radical before you put in your plus 5. Okay, does everybody see that? Once you have that in, we hit graph and look at the pretty picture. Now the picture's nice. Doesn't tell you everything though. What would tell you everything? What do you need to use? What function on here? Yeah, get the points. Go to your table. Second graph, good. Okay. Now, depending on where you have your calculator starting, you might be in a different place, but look at where mine starts. Mine starts at -1, and its y value says error. See that? Okay. So error, -1, 0 error, 1 error. All these are errors because, when you look at the graph itself, the graph is x minus 2. Right? That's what we're working with, the square root of x minus 2. So then we go to look at the next point. Let me arrow down there. And 2 gives us 5. Okay? See that? So that is the first point of the graph. Okay? So I'm going to go back here now. So we can plot a point at 2, 5, right there. And then the next one is 3, 6. And the next one, and you only have to do, nice ones here, okay? Because there'll be a bunch of not nice ones in between. Your next one's what? 6, 9? Is that right? 6, 7. Oh, duh. Yeah. Okay. And then these will eventually get to the point where you're off the graph somewhat quickly. So you might only be able to get to 3 points, and that's okay. And then just play connect the dots. Okay. So a basic graph, plug it in your calculator, go to the table function, pull the points off, plug them in. Okay. I'm going to go back to the calculator for the domain and range part of this problem. So is everybody good with the graph itself? Yep. All right. Now the domain and range part, this card, escape. The domain and range are basically asking you, okay, so what numbers can you put into this, and what numbers will you get out of this? Okay, because remember, domain are your x's, and range are your y's. Okay, so let's do domain first. Domain, x's that are going to be greater than or equal to what number? 2. Why 2? That's where it starts. That's exactly it. Okay? It starts at 2. It's the first x that gives you a good point. Everything before 2, 1, 0, -1, 0, or -2, -3, they will all give you errors. So your first good point is x of 2. And then every x after that, right? 3 is good, 4 is good, 5 is good, 6 is good. That's why you put the greater than or equal to. Make sense? Now your range is your y's. They'll be greater than or equal to 5. Because if you look at your y column, same deal. We start at 5. It's the first y that comes out. Go to 6. Go to 6.4142. 6.7321, and it keeps going up from there as you scroll through your table. And that's it. Domain of x is greater than or equal to 2. Range is y is greater than or equal to 5. So this next one's a little different. Alright, y equals, clear that out. First off, it's being multiplied by negative 2. Alright, square root of what, x plus 3? Then a minus 1 on the outside, is that right? Yeah, okay. So now notice how this one's going to be different once you hit graph. Alright. Instead of going up and to the right, this one's going down and to the right. Alright, now, maybe obvious, but why do you think that is? The negative in front, good. Okay, it's going to flip the whole entire graph. Alright, which doesn't change a whole lot about how you take these problems and what you do to them, because to graph it, you're still just going to your table and looking at what your table gives you. Okay. Now, the only bad part, it's not really that bad because, you know, it's not terrible, you have to go find the starting point. Right? It won't always just give it to you right there. So you have to go look for it time to time. So here it is at negative 3, negative 1. Okay? So let's see, we go negative 3. So we go over here. We go negative 3, negative 1 right there. Negative 2, negative 3 right there. 1, negative 5. Does another one fit? Or did you just do those 3? Anybody know? Just do those 3? Or is there a fourth one that fits?
I did.
Ooh, okay. Well, either way. And then just play. Connect the dots. Once again, you don't have to be perfect. See how I kind of missed that right there? Okay. As long as your dot's where it's supposed to be, I'm not going to get too picky if you miss it accidentally. They're hard to draw freehand. Okay, it's like drawing a parabola. Okay. So don't worry too much if you... Now, obviously, if you go like way over here, I'm taking off points, but if you go through more or less where you're supposed to be, you'll probably be okay. All right. Everybody good on that picture? Yeah. Okay, so then for the domain and range for this guy, it does change just ever so slightly, but your best bet is always to look at that table for domain and range. Okay, so if we look at that table, domain is our x's, and our x's start at negative 3 and go up. See that? We go negative 3, negative 2, negative 1, 0, 1, 2. So the x's that work are all x's that are greater than or equal to negative 3. Okay, what about your range? What happens here? What's different? Good. You're going down. See that? You go from negative 1 to negative 3 to negative 3.828 to negative 4.464 to negative 5 to negative 5.472. You keep going down. That's because of that negative also. Okay? So y's that are less than or equal to, you still use your start point of negative 1. All right, now let me zoom out here. Hold on. Hello. There we go. Okay, last problem. Write the equation of the square root function that's shown. Now, in order to do this problem, we need to go backwards. Okay, go back to this slide here. I said I was going to skip over. I didn't say we were going to completely skip it. Okay, and from this slide, we need that part. And honestly, we can change f of x and make it y. Y equals a square root x minus h plus k. Y equals a square root x minus h plus k. And to avoid the clutter, I'm going to go back over here to define it. Okay? So we got y equals a square root x minus h plus k. Okay? 1, 2, 3, 4, 5. 5 variables, and we got to know what all 5 mean and what all 5 represents. All right, so let's start with the easiest ones. X and Y. Domain and range. Those are the X's, those are the Y's that are actually on your graph. Right? Just like how whenever we did slope-intercept form, we would pick a point, we could put it in for X and Y. Same thing here. Okay, so X and Y. Let's get some cute colors going. X and Y are points on graph. All right. Next one, H and K. All right, H and K is your starting point. Okay, which means it's a coordinate, right? If it's going to be a starting point, it's going to be a coordinate. It's going to be an ordered pair. How do you think that ordered pair goes? HK or KH? Think about it. HK or KH? A, B, C, D, E, F, G, HK. Good. Whoops, that was a terrible K. I don't know where that came from. It goes alphabetical. Still a terrible K. That's better. Okay. H is the X coordinate of your starting point. K is the Y coordinate of your starting point. Okay. Everybody good? Which leaves us with what? A. Leaves us with A. Now, there's two ways I could go about teaching you this. I could go into the very complicated words and the complicated definition of A and how it does this and how it does that and blah, 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 blah. Or, essentially, A is your slope. Essentially, A is your slope. A is the slope when you're talking about the square root functions, okay? Now, obviously, it doesn't go rise over run because this is not going up at a very consistent manner, right? It's not a line. Line goes up in a very straight, wow, that's a very good way to explain it. A straight line goes up in a very straight way. That's just insightful teaching there, okay? But A is going to determine how fast or how slow this guy does rise or go. Okay, so it is kind of like a slope, and that's probably the easiest way to explain it to you. Okay, does everybody have that written down on their paper somewhere? Yeah? Everybody good? Okay, so I'm going to, let's see here. I'm going to take this all. I don't want to do that. Hold on. Take this all, and move it up there so we can't necessarily see it, but we don't forget about it. Okay? So to do this problem then, we need to go figure out what as much as we can about this graph. Okay? So let's start with the starting point right there. Mark him in red. Okay. Looks like a starting point of 2, 3. Everybody see that? White was a poor choice for X and Y, so I'm going to change them to black now, so that way we can see it. Now, X and Y are whatever point you have on the graph, so it can be any point that's on the graph, but for your purposes, you want to make sure it's a good point that's like goes through evenly. So I would say probably like right here, which is the what, 0.64? Okay, let's see that. So here's X, here's Y, here's H, here's K. Okay, so we have 4 of the variables right there. The only one we're missing is what? A. We don't have A. And here's the bad part. By looking at the graph, and that's it, there's really no good way to know A or find A. So here's what you do. You take everything you got. We know Y is 4. We don't know A. We know X is 6. We know this is a minus. And we know H is 2. And on the outside we know K is 3. You take everything, you plug it in, and you solve for A. Okay. So, a couple different things you could do here first. What do you guys feel like? What draws your eye? Square root. What about it?
What's inside the square root?
Good. Do inside the square root first. Okay, so 4 equals A. Square root 6 minus 2 is 4 plus 3. Okay, now what? What do you want to do next? Square root 4, okay? So that gives you 2, right? I'm going to do a switch on you. Instead of A2, I'm going to make it 2A. Is everybody okay? Which I advise you do, okay? I advise you do that part, okay? Now the instinct should really be kicking in. What's next? Subtract 3. And then divide by 2. So A equals 1/2. Okay. Now the reason why I wanted to see what your instinct said up here, I like the way you did this. By the way, okay, I like the way this problem was done. The only thing you could have done differently, or you could move this subtract 3 step at the top. Okay. There's nothing wrong with subtracting 3 off right there right away. Nothing else changes though. Okay. Still got to do the inside of the square root. Take the square root, divide it over. I like the way you guys did it though, okay? Now, you're almost done. You're not quite done. You found A, but the question says write the equation. All we have is A. So write the equation. So Y equals 1/2 square root X minus 2 plus 3.